The problem with that asteroid that destroyed dinosaurs was not that it fell, but where it fell. This colossal space rock found the worst place where it could land. Also, the angle at which it hit the ground was the most unfortunate. If it had fallen vertically, there would have been less destruction. But it fell at such an angle that it threw a huge amount of dust into the air. After the disaster occurred, tons of soot started burning. 65 million years ago, only 13% of Earth's surface contained the right amount of sulfur and oil needed to form a colossal amount of soot. If the asteroid had fallen on the other 87% of the territory, dinosaurs could still be living today, but it hit the worst place and lifted 1 million tons of burning material into the sky. A cloud of incandescent particles covered the sky and set off on a journey across the mainland. Then, these particles settled on the ground and caused large-scale fires. Trees were burning and sending more soot into the sky. But the asteroid collided not only with rocks, it fell on the coast in a place where the seabed was filled with sulfate. As a result of the collision, it started burning, which caused the release of sulfuric acid into the atmosphere. The air became poisoned. It seems the dinosaurs didn't stand a chance. And now, let's imagine the asteroid falling in another place, somewhere in the middle of the ocean. Huge waves flooded part of the land, but almost all kinds of dinosaurs survived. Or even better, the rock could have fallen somewhere in the desert and left behind a giant crater. That's all. Yes, several dinosaurs passing by wouldn't have survived the collision, but the situation wouldn't have been so critical in general. So, giant lizards remain dominant on our planet. They don't allow other animals to develop since Tyrannosaurus and other ferocious reptiles hunt mammoths and other ancient creatures. The population of mammals is decreasing. Velociraptors are fighting for territories with saber-toothed tigers and giant bears. A struggle for survival between dinosaurs and other animals begins. Then, the Ice Age comes, and some reptiles don't survive. Then, new players enter the field. Those are humans' early ancestors. Living side by side with dinosaurs is difficult. Lizards attack settlements and caves, so people have to build high walls for protection. By the way, the Tyrannosaurus poses less danger to people than you might have thought. According to the latest research, many creatures were able to run away from this monster. Yes, you probably saw how easily they caught up with cars in the movies, but it wouldn't be as scary in reality. Paleontologists and biologists have analyzed the strength of dino's bones and found out that the creature couldn't reach high speeds. The maximum it was capable of was running twice as slow as a field athlete. Thousands of years have passed. People have learned to live with dinosaurs. They've even managed to tame some lizards. They've domesticated herbivorous dinosaurs to develop agriculture. Triceratopses and bulls now plow fields together. Imagine farms swarming with diplodocuses or brachiosauruses. People climb their long necks and pick fruit from high trees. Stegosauruses protect pastures from wolves and velociraptors. Dinosaurs with shells, such as ankylosauruses, help people cross deserts. They, along with camels and donkeys, carry heavy loads. People share the planet with ancient lizards and live in harmony. The situation in the seas and oceans is much worse. Sea reptiles attack wooden ships and catch all the fish. Imagine that you're sailing to another continent with tons of grain, fabrics, fur, and other goods. And then a giant mosasaur appears on the horizon. It's one of the most powerful sea lizards. A great white shark looks like a small fish next to it. The creature could easily defeat a megalodon. And then it comes across a wooden ship. It bites into the deck and pulls the whole boat underwater. Water dinosaurs are the main obstacle to communication between countries. This slows the progress down for 100 years. People built metal ships to withstand the attacks of the mosasaur. And finally, they managed to establish sea connections. A similar problem occurs when the first planes take off into the sky. Imagine you're flying on a passenger Boeing. You look out of the window and see a pterodactyl. Wait, it's impossible. These winged lizards aren't so fast, but they can catch up with a helicopter or some old biplanes. This poses a serious threat to flights, so people install sound protection systems on board each aircraft. Pterodactyls hear irritating ultrasound from a distance and fly as far away from it as possible. People equip submarines and ships with the same sound shields. Then, after people have learned how to defend themselves from dinosaurs, another problem appears. Lizards are the kings of wildlife, so they displace all other animal species. Dinosaurs run across African savannas, and lizards with fur live in cold winter forests. Lions, wolves, and bears are not the rulers of the wild. Rhinos fight with Parasaurolophuses. Stegosauruses attack hippos and take away their territories. Venomous dinosaurs live in jungles. Lizards that can climb trees scare monkeys. Imagine a reptilian ape jumping from one branch to another. To save regular animals from extinction, people have to control the population of predatory reptiles. Huge parks and nature reserves appear in all countries. People transport dinosaurs there and separate them from other wildlife. Dinosaurs seem to be completely under control. When the danger caused by giant reptiles passes, people begin to breed smaller, harmless lizards. Someone buys a chameleon, and someone keeps a Microceratus at home. There are dinosaur exhibitions. People take these creatures for a walk as if they were dogs. Some people take selfies with reptiles, go shopping, and sit in cafes with small lizards. Dinosaurs aren't formidable now. They're kinda cute. People ride horses, camels, Parasaurolophuses, and Pachycephalosauruses. Of course, many have tried to tame velociraptors, but failed. Those are dangerous reptiles and they don't know how to obey. Taming them is almost as difficult as taming an alligator. But dogs and cats are still more popular because they're more intelligent. The brain of a dinosaur is almost the same as that of a chicken. But who knows, if they had lived to this day, perhaps they would have evolved into smarter creatures. Just imagine if dinos were intelligent. In this case, people would have a big problem. Some scientists think that even if a meteorite hadn't destroyed the dinosaurs, they wouldn't have survived to this day. They needed to carry their own colossal weight at all times. It was an enormous load on their bones and joints. Most dinosaurs wouldn't have been able to survive the Ice Age with such characteristics, but smaller lizards might have succeeded. Fast and agile dinosaurs, such as velociraptors and Pachycephalosauruses, would have survived, but in what form? Could dinosaurs have already evolved into something else? Look at the good old chicken. Many scientists believe it's a direct descendant of the formidable Tyrannosaurus. Somewhere deep inside the bird's DNA, there are genes that the dinosaur had. Yep, it's hard to believe, but look at the chicken's body structure and how it walks. Remove the plumage, cover the creature with scales, and give it toothy jaws instead of a beak. And now, you have a mini T-Rex in the coop. And by the way, not only chickens might be the relatives of giant lizards, many birds are dinosaurs' living descendants. Surprisingly, alligators, snakes, crocodiles, and monitor lizards are not as close to ancient reptiles as pelicans, storks, and other flying creatures. Over millions of years of evolution, the paws of dinosaurs turned into wings, and toothy elongated jaws ended up as beaks. The genetics of birds is the key to understanding dinosaurs. Pelicans are similar to pterodactyls, ostriches to velociraptors. Perhaps many other animals also share some genes with ancient lizards. If the meteorite hadn't fallen, all dinosaurs would have evolved into completely different, unusual creatures. Scientists want to carefully study the DNA of birds and try to reverse evolution with the help of genetic engineering. They hope to breed dinosaurs out of eggs one day. But to do this, they need to find a specific genome that hasn't changed over tens of millions of years. It hides in the DNA. And it's not so easy to find it and extract it. Do you think we will see powerful reptiles by 2050?
That sound is the explosion of a supersonic wave. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. It weighs trillions of tons and is flying towards the Earth at an incredible speed of 12 miles per second. It would fly from New York to Anchorage, Alaska, faster than you can fry an omelet. Don't worry, we're safe. The dinosaurs that ruled the planet at the time, however, not so safe. This was a bad day for them. This disaster began in the area we now call the Yucatan Peninsula, modern Mexico. The meteor did make impact on the ocean, but the water did not extinguish it. The collision caused a huge amount of energy to be released, which began a cataclysm on a planetary scale. Imagine another sun lit up on the surface of the Earth. The initial blast actually blew through the surface. It was as hot as an oven and burned everything in its path. It set up a tsunami as high as the Statue of Liberty from the epicenter. The impact also provoked a colossal earthquake and volcanic activity. Several nearby volcanoes simultaneously released hot lava from their calderas. Millions of tons of ash and soot were released into the atmosphere, poisoning the air. This formed a huge ash cloud in the atmosphere, which for several years didn't allow the sun's rays to reach the Earth. The long nuclear winter began. Only it wasn't snow that fell from the sky, but a rain of sulfuric acid. Yes, it's safe to say that Chicxulub is one of the most devastating culprits in the history of our planet. In fact, why don't we have ourselves a trial against this space monster? Let's investigate this 66 million year old crime. Thanks to scientists' efforts over the years, we have plenty of evidence. I'll be the judge. In the name of space law, I give the floor to the prosecutor. Respected judge, jury, today it is obvious to all that it was this asteroid that led to the extinction of our beloved dinosaurs. Some more beloved than others. T-Rex. There are other suspects. Volcanic eruptions, a lot of oxygen in the atmosphere, a supernova explosion, temperature changes, the list is very long. But scientists have, without a shadow of a doubt, determined the truth. This asteroid left a crater on the planet's surface with a diameter of 93 miles and a depth of 12 miles. Though this scar is hidden under the ocean water, it can still be seen today. The perpetrator did attempt to hide evidence, as the temperature at the center of the collision was so hot it vaporized part of itself, but not nearly enough. We know that lots of asteroids are abundant with the material called iridium. The fragments off this rock contain 300 times the normal amount. And research shows these fragments are exactly 66 million years old, just like the defendant. This is the definitive proof of guilt. Furthermore, the defendant knocked 25 trillion tons of hot rock out of the Earth. The debris of the asteroid mixed in with the Earth's material, and the immense heat turned the stones into glass. Scientists call these tektites. The energy of the impact threw them into the atmosphere, and after a short flight upward, the tektites then fell down upon the Earth. It was like a rain shower, only instead of water, it was a rain of hot fireballs. They bombarded the planet's surface for 24 hours and set fire to everything they fell on. Scientists have found traces of them all over the world. These are undeniably shards of Chicxulub. I rest my case. Respected prosecutor, your evidence is very convincing, but our judgment must be objective. We now give the floor to the defense. Your Honor, I believe this is a terrible misunderstanding. My client isn't some space offender. It's simply the victim of cosmic circumstances. In fact, the asteroid Chicxulub isn't even an asteroid, but in fact the fragment of a comet. These aren't my words. These are the conclusions of a study conducted by a group of astrophysicists at Harvard University. Asteroids are made of stone and metal. Most often they resemble the shape of a potato. Comets, on the other hand, contain rock, metal, and ice. They look like dirty snowflakes with ammonia, methane, and carbon dioxide mixed in. Most comets come to us from the Oort cloud. This is a large accumulation of ice debris around our solar system. Due to the elongated orbit of flight, from time to time, comets emerge from this cloud. So occasionally a cosmic snowball crosses the barrier and enters our solar system. This is what happened to my client. According to scientists, Chicxulub's flight path put it dangerously near Jupiter, which, with its impressive gravitational pull, accelerated Chicxulub's velocity and put it on a collision course with the Sun. The sun's heat then evaporated the comet's outer coating of ice and dust, which formed a tail. But even before making impact, the sun's gravity shattered the comet apart. One of those fragments was the one that flew through space and crashed into the Earth 66 million years ago. Yes, there is some debate among scientists on this hypothesis, but regardless of the details, one thing is certain. My client did not intend to crash into the Earth 66 million years ago. Circumstances conspired it to be so. You're on. All right, I have listened to both sides, and I've made my decision. In the name of the Space Court, I declare that the defendant is acquitted. Well, that was a bit of fun. The truth is that space rocks like Chicxulub are a dime a dozen. There are millions of them bumping into one another in the vastness of space. The Earth was just unlucky enough to be in the path of this one. Though the impact it's had on the planet cannot be overstated, this catastrophe ended the development of 75% of life on the planet. Some marine animals did survive the impact, for example, crocodiles, turtles, and fish. Of the inhabitants on land, the only animals to survive were tiny creatures, no larger than a modern raccoon. Among them are several species of avian dinosaurs, which are actually the distant ancestors to modern birds. Scientists believe they survived for two reasons. First, unlike most herbivores that relied on grass for their diet, these dinosaurs had beaks, which they could use to split nuts and dig out seeds. So even when most of the plant life was gone, they could still subsist on what's left. Secondly, these dinosaurs' brains were larger than those of most. This means that avian dinosaurs could cooperate with each other and quickly adapt to new conditions. Lots of fungi and mold also survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape once again. Thousands of years later, forests reappeared on Earth. One unexpected benefit to this disaster is that it allowed for the emergence of the rat-like mammals that are the ancestors to modern humans, as well as whales, bears, and even the platypus. Back before the incident, these mammals would live in the shadow of their dominant dinosaurs. But their disappearance created a biological vacuum. Thus, these mammals were able to quickly occupy that vacant niche and become the new dominant group on the planet. According to multiverse hypothesis, many parallel worlds exist simultaneously with our own. Let's imagine that this is true and that we found a way to travel to these worlds. Let's board a ship to fly through space and time. Our destination is a universe in which the asteroid flew past the Earth. In this reality, the domination of the dinosaurs was never interrupted. Earthquakes, tsunamis, ice ages, volcanic eruptions, the dinosaurs survived all these minor cataclysms. Most of the lizards have changed and are now unrecognizable. Due to the onset of the ice ages, many dinosaurs here are covered in feathers that protect them from the cold. Mammals also exist, but they're few and far between. You see some bats in caves, and there are many rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, elephants, or other large mammals in this world. Why become large and noticeable if there are so many dangerous reptiles with big appetites around? There are no whales in the sea. There are no parrots, hawks, or pigeons in the sky either. But you can see creatures similar to pterodactyls soaring past. Some are about the size of a helicopter, while others are no larger than a swan. There are also primates, but they're in no hurry to climb down from trees and walk on two legs. In our real world, our primate ancestors settled in the savannah, where, because the distance between trees was much wider, they started walking on the ground between, eventually standing upright and evolving into Homo sapiens. In this world, open spaces are still very dangerous, so these primates stayed in the trees and evolved to more resemble a lemur, not a chimpanzee. So of course, humans have never emerged on this planet. This means there are no roads, cities, cars, or space satellites. But flowering plants did evolve, as did many fruit trees. Many small dinosaurs would have evolved to feed on these fruits. This did also happen in our world, back in the Cretaceous period just before the failed collision of the asteroid with the Earth. The dinosaurs of this planet have grown wiser, reaching the level of a modern chicken. But a large brain uses a lot of energy, and enlarging it is not always a good strategy for survival. What's good for a primate in the mammalian world isn't always good for a dinosaur in the reptile world. Thankfully, this isn't our world at all. In our world, that asteroid really did wipe out the dinosaurs. They didn't stand a chance. What's interesting is it wasn't really the size of the asteroid that made the impact fatal, but where and how it hit the Earth. When measuring meteor impact, one important factor is the angle of incidence, which determines the kind of fallout to expect. Chicxulub hit the Earth at a 60-degree angle. This was the worst-case scenario. At that angle, the impact knocked a lot of water vapor and carbon dioxide into the atmosphere, but more importantly, lots of sulfur. This substance stayed in the atmosphere and formed aerosols, which are tiny particles that blocked the sun's rays. Without the sun, plants disappeared and the climate became colder. If the angle of impact was any different, then the dinosaurs could have survived this catastrophe. As cool as dinosaurs are, I'm glad I can go outside and not have to worry about a random raptor attack or a triceratops stampede. So as devastating as Chicxulub was all those 66 million years ago, I guess I'm glad things played out the way they did. We wouldn't be here otherwise. Thanks for watching.
From tiny critters to colossal creatures, all animals are trying to escape from a wall of fire moving in their direction. The temperature is rising, and everything around starts catching fire. Soon, lots of animals and plants on Earth will cease to exist. This is the aftermath of a giant asteroid crashing into our planet. But what if dinosaurs had had critical thinking skills? They could have guessed what was going to happen, because this asteroid was visible a year before the impact. 1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub impactor now holds first place among the brightest objects in the sky. The light surrounding it, called a halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub impactor is brighter than the full Moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid's shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub impactor is now approaching the ground. A few more feet and bam! The night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub impactor with an enormous amount of energy. In the next moment, a super powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They in turn generate tsunami waves as high as the Empire State Building. 5 minutes after the impact, the meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air. Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface non-stop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness, and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon, they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. Anyway, if we know about the approaching space body, we'll be able to build shelters filled with food and water supplies. Once the asteroid is close enough, we can wait for the impact and its consequences inside. But when people come back to the surface, they'll see cities and towns torn down. Our planet will look like a lifeless desert. That's why we need another alternative, which is to prevent the impact. Here, we have many options depending on the size and material of the asteroid. According to NASA, the most effective way is a kinetic ramp. We'll need to send a fairly large and heavy object, such as a spaceship, into space. When it approaches the asteroid, scientists will choose the perfect trajectory, and the ship will crash into the space body. A powerful collision will change the asteroid's course, making it fly past Earth. The further this space body is from our planet, the easier it'll be to send it away. Another option is a controlled explosion on the surface of the asteroid. Newton's first law of motion will help us here. It says if a body is moving at a constant speed in a straight line, it will keep moving that way unless it is acted upon by a force. So, if we make a big enough explosion, or force, the asteroid will shift its trajectory. How much it moves depends on the amount of force applied to it. We can also blast the asteroid right from inside. In this case, there will be no need to change its trajectory. Instead, we'll try to turn one huge hunk of rock into a bunch of smaller fragments. They will burn up in the atmosphere and do no harm to our planet. Another way is a gravity tug. Every heavy object has its own gravitational force and gravitational field. Our goal will be to send a spacecraft to the asteroid and make it fly close to the intruder. The asteroid will attract the spaceship, but its engines will resist. As a result, the ship will slowly but surely pull the asteroid toward itself. This method will take much longer, but gradually, the trajectory of the asteroid will change and it won't crash into Earth, hopefully. We can also use solar power. We can build a spaceship with a system of giant magnifying lenses. Then we'll send that station closer to the Sun. When we spot an asteroid, we'll point the lens in its direction and focus the beam on the space body. The heat from the Sun will cause the asteroid's material to evaporate. Eventually, this will make the intruder change its trajectory. 66 million years ago, I wasn't around then, a huge asteroid hit the Earth and triggered the mass extinction of almost all living creatures on the planet, including dinosaurs. Had the space object crashed somewhere else, some dinosaurs would have been able to survive and still live nowadays. According to some research, the asteroid had about 1 in 10 chances of wiping out the dinosaurs and other animals of that time. It was way more likely to just hit the ground without any strong destructive consequences. To understand how things could have turned out if the place of the collision had occurred elsewhere, we need to find out what happened that day and why the disaster turned out to be so devastating. This huge space rock fell into the coastal area of the Yucatan Peninsula in Mexico. This caused a chain reaction that triggered natural disasters around the world. The place the asteroid hit is called Chicxulub crater. Now half of this area is underwater. The asteroid was about 7.5 miles in diameter and moving at a speed of 27,000 miles per hour. This rock, bigger than Everest, was rushing toward Earth faster than the speed of sound by almost 40 times. Wow. The energy released in the collision was as powerful as an explosion of about 10 billion atomic bombs, and the destructive force of the blast wave was just one of several disasters. The asteroid happened to fall in one of the worst possible places, and because of the way it fell, it threw a huge amount of dust into the air. Imagine you're jumping into the water like a professional athlete vertically, leaving hardly any splashes behind. And now think of how much water splashes when you jump into the pool like a cannonball. So the asteroid landed the cannonball way. The second disaster the asteroid provoked was soot burning. A small part of the Earth's surface consists of rocks. Only a tiny percentage of that part was rich in oil and sulfur back then. The asteroid burned and lifted so much soot into the air that it would be enough to fill an indoor baseball stadium. According to research, 65 million years ago, only 13% of the surface of the entire planet could have contained the necessary amount of organic material for the formation of such a volume of soot. That's why this place was considered the worst. If the catastrophe had happened on the territory of the other 87%, then dinosaurs would have been alive today. A huge cloud of soot and carbon dioxide rose into the air and covered the sun. The soot turned the sky gray and partially blocked sunlight. This led to a quick drop in temperatures almost all over the planet. It seemed like Earth was inside a gray veil. Many plants and animals couldn't survive the cold snap. Trees began to wither because of the lack of sun. The photosynthesis process was disrupted. The cold and withering of trees led to another catastrophe: global famine. Herbivores couldn't survive because they lost almost all of their food. Plants, flowers, and trees didn't manage to get through the catastrophe. These destructions spread far beyond the asteroid impact site. Hot dust particles, asteroid chunks, and small pieces of rocks settled to the ground across the continent and caused large-scale forest fires. Burning trees threw even more soot into the air, which made the situation even worse. The huge asteroid brought heavy metals with an increased level of toxicity from space. The melting of these substances during the collision provoked firestorms. The asteroid didn't only hit continental land but also water, which triggered a huge tsunami. But that's not the worst part. The seabed was filled with sulfate, and when the energy of the asteroid burned it, it provoked the release of sulfuric acid into the atmosphere. The acid cloud mixed with a cloud of soot and began to spread throughout the sky. Hot rock particles were falling to the ground like fire rain. An acid rain started because of sulfur. It lasted for almost several days and left no chance for the animals to survive. Acid rain made the water in rivers, lakes, and seas poisoned. The acid destroyed anything that couldn't burn. A part of the clouds went to wreck the land, and the other part, the ocean. This made the situation even worse, as sulfur droplets wiped out a huge amount of seaweed and phytoplankton. The ocean generates almost half of all oxygen reserves on our planet. Those days, the sea creatures living in its upper parts were destroyed. It wasn't the blast wave, but lack of sun, acid, darkness, and cold that became the main reasons for the extinction of dinosaurs. But even when some lizards escaped from fires and sulfur, they met the sea element. The asteroid impact caused large-scale tsunamis across the planet. The very first wave was around 1 mile in height. That's almost 3 times higher than the Empire State Building. Billions of gallons of water were moving at 90 miles per hour. A wave this strong could easily destroy half of New York today. The meteorite created a series of waves 52 feet high. Massive walls of water the size of 5-story buildings collapsed on the shore and demolished everything in their path. Lack of sunlight, temperature drop, acid and fire rains, reduced oxygen production, forest fires, giant tsunamis, and the explosive wave with the power of 1 billion atomic bombs. All this reduced the biological diversity of Earth by 75%. Yeah, that'll change your climate for sure. Giant asteroids used to hit Earth before, but they never caused such disasters all over the planet. What if this asteroid had fallen into another place, say a forest, far from water and mountainous terrain? This would have caused severe fires. A huge black cloud of ash would have risen into the sky and obscured the sun. But it would have unlikely generated acid or fire rains. Most of the species of the planet could have survived this catastrophe. What if the meteorite had fallen somewhere among the ice and snow? This would have provoked a rapid increase in temperature across the planet. Huge tsunamis would have sunk big tracts of land. However, ash and sulfur dioxide wouldn't have filled the sky. Acid rain wouldn't have hit the ocean. Many marine creatures could have survived and lived to this day. And dinosaurs, far from the oceans, wouldn't have noticed the meteorite fall at all. Probably the most terrible events would have occurred if a meteorite had fallen on an active volcano. This would have triggered the largest lava release in history. Destructive earthquakes would have begun, and the whole sky would have been covered with volcanic ash. What if the meteorite had hit some desert? It would have melted billions of tons of sand and turned it into glass. Just imagine glass dunes that heat our planet even more. And we could dig up the well-preserved remains of ancient lizards out of the glass. Anyway, there were many different possible catastrophic scenarios, and the worst of them came true for the dinosaurs. They are unlikely to return, although perhaps they can be reborn. Scientists were inspired by an idea from a famous Hollywood movie. They wanted to find a mosquito that got stuck in amber. They would extract dinosaur DNA from it. But there was a problem with this. The oldest DNA sample they managed to find was 1 million years old. Dinosaurs were extinct about 66 million years ago. Besides, DNA is a very fragile thing. The probability that it could have been preserved intact somewhere for so long is very small. So, instead of searching for this ancient dinosaur DNA, scientists decided to take DNA from the closest ancestors of these lizards, birds. Over millions of years of evolution, dinosaur paws could have turned into wings, and elongated mouths could have become beaks. Pelicans are very similar to pterodactyls, ostriches resemble velociraptors, and chickens are very much like T-Rex. Okay, let's just stop and imagine for a moment a chicken the size of a T-Rex.
Hey, you want a piece of me?
Now, the common chicken is recognized as the closest relative of the huge lizard. Remove the plumage from it, cover it with scales, give a toothy mouth instead of a beak, and attach a long tail. And you get a real mini Tyrannosaurus rex by body structure and movement. Deep in its DNA, there are similar genes that formidable predators have. With the help of genetic engineering, scientists plan to play with its DNA and try to reverse the evolution, which means breeding dinosaurs can become a reality. Well, that could come back to bite you.
Imagine wildfires raging across the continent, tsunamis crashing against coastlines, and almost 75% of species on our planet going extinct. That's what happened when the most devastating asteroid we know about hit our planet. Yes, I'm talking about the one that wiped dinos off the face of the Earth. But I've got some shocking news in store. This asteroid might have had a companion. Scientists discovered something that might be an impact crater 250 miles off the coast of West Africa. They were looking at the data from the seismic waves that the researchers had sent underground. Their goal was to check the ocean floor's terrain by observing the waves ripple through Earth. That's when they spotted a large bowl-shaped structure with a broken-up floor and a central peak. These features are very common for an impact crater. But the most unexpected thing was that the timing of this potential asteroid strike, which seemed to occur around 60 million years ago, could make it a sibling of the dinosaur-ending Chicxulub asteroid. This second asteroid might have broken off the main one, or they could have been part of a closely timed impact crater. You, along with many other people, might have questioned yourself, how come just one asteroid could have caused so much destruction that we don't see dinosaurs roaming the planet anymore? Well, that second asteroid might have helped. Researchers dubbed the crater it supposedly left the Nadir crater. The name comes from the nearby underwater volcano. The discovery itself happened in 2020. It hasn't been confirmed yet that the crater was caused by an asteroid. But its features, including its scale, the height of the crater rim, and the ratio of height to width, most likely mean an impact origin. Plus, the deposits surrounding the Nadir crater look like something ejected from a crater after a collision. Scientists created some computer models and figured out that to cause such an impact, an asteroid had to be around 1/4 of a mile across. Even though the Chicxulub itself was way larger, around 6 miles in diameter, the second hit would have been pretty impressive as well. The energy released at the moment of the collisions would have been more than 1,000 times greater than the eruption and tsunami in Tonga in January 2022. The hit would have also produced shockwaves equivalent to a magnitude 6.5 to 7 earthquake. It would have triggered underwater landslides, as well as a series of tsunamis. In any case, discoveries of such terrestrial impact craters are always a big deal. They're quite rare. Researchers have found fewer than 200 confirmed impact craters on Earth. Almost all of them have been discovered on land. There are also several likely candidates, but their origin hasn't been confirmed yet. What can the newly found crater be if it wasn't left by an asteroid? It could be a collapsed volcanic caldera, or it could be a salt diapir, which is a squeezed body of salt. To confirm that the Nadir crater was created by an asteroid strike, scientists need to drill into the formation and gather samples. The evidence scientists are looking for might be shocked quartz, a mineral that appears when asteroids crash into our planet. If we do find it, we'll hopefully learn whether this discovery has any connection to the Chicxulub. Its fall led to terrifying consequences on Earth. The asteroid is believed to have come from the outer reaches of the solar system. When it crashed into the planet, the force of the collision was so powerful that the space rock didn't stop until it got through Earth's crust to a depth of several miles. The impact left a crater more than 100 miles across. Thousands of cubic miles of solid rock instantly turned into vapor. The crash set off a series of natural disasters that erased around 75% of plant and animal species on Earth. Animals that were close enough to see the crash didn't survive for longer than a few seconds. Close to the impact crater, the ground was covered with thousands of feet of hot ash, grit, and rubble. Several seconds after the collision, everything, for many miles around, burst into flames. what didn't burn down within the next several minutes faced a different, even more terrifying problem. The asteroid also produced a monstrous, largest ever tsunami. A recent study claims that it was thousands of times larger than any wave people have ever seen. You see, the splashdown was so powerful that it left its signature on the face of our planet. In 2021, researchers found out that the collision had carved mega ripples into the Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists even remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. And of course, all that empty place didn't stay empty for long. The ocean gushed back to fill the crater, but in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall and moved at a speed 10 times greater than more distant tsunami waves. During the first hours after the crash, the sky was almost totally dark. Later, it started to get lighter, but very, very slowly. For the next couple of years, the world seemed to be stuck between a cloudy day and twilight. Lots of plants didn't survive this dimness and the absence of sunlight. The ash stayed in the air for months. That's why when it rained, the water became highly acidic. Fires kept raging. They produced tons of toxic gases that destroyed the ozone layer, at least for some time. The gases and particles that had been flung into the atmosphere blotted the sun out. This caused temperatures to plummet by over 60 degrees Fahrenheit. Lots of plant and animal species that managed to survive the impact itself couldn't stand these new hostile conditions. By the way, the infamous asteroid could have also been part of a shower, since there's some evidence that many other space rocks smashed into the moon at approximately the same time. In December 2020, some glass was found on the moon. It could have been forming there over billions of years as the soil was ejected during asteroid impacts. The discovered glass was delivered to Earth by the Chinese National Space Agency's Chang'e 5 lunar mission. Researchers have concluded that the super tiny glass beads were indeed created by the heat and pressure of meteorite impacts. It means that their age should be the same as the time of the collision. Using the glass beads, scientists managed to create the timeline of such collisions. They think the timings of asteroids hitting the moon could mirror the impacts of asteroids hitting our planet. Even more exciting, scientists have found out that the age of some lunar glass beads coincides with the age of some of the largest impact craters on Earth, including the Chicxulub impact crater. If this theory about smaller impacts accompanying large impact events on our planet turns out to be true, we'll get important information about asteroid impacts on Earth and the inner solar system. Now, researchers are planning to compare the data received from the Chang'e 5 samples with other samples of the lunar soil from different craters. It may reveal new evidence about what impacts may have influenced life on Earth.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernardinelli-Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space, Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli-Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli-Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli-Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli-Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli-Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the Sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the Sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the Sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
Boom! An explosion of supersonic waves, interplanetary heat, dust, fumes. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. A few seconds ago, this rock, weighing trillions of tons, was hurtling towards Earth. It could fly from New York to Anchorage faster than you could fry yourself an omelet. This monster's name? The Chicxulub incident. Epic name, right? 66 million years ago, it crashed into the Earth. Back then, dinosaurs ruled the planet, but not for long. The epic collision took place in modern Mexico, in the Yucatan Peninsula, right near Cancun, where the dinosaurs were vacationing. Well, probably not. Still, the huge space rock hit the ocean, but even all that water couldn't stop the inevitable. The collision caused a huge amount of energy to be released. The horror on a planetary scale had begun. Imagine a mini-sun lighting up the surface of the Earth with tsunamis the height of the Statue of Liberty bursting from the epicenter of the watery impact. Not good. The blast blew through the surface of the Earth. It was as hot as an oven and burnt everything in its path. The impact provoked a colossal earthquake and serious volcanic activity. A bunch of volcanoes simultaneously released hot lava and ash into the prehistoric skies. Millions of tons of ash and soot poisoned the air. This formed a huge ash cloud in the atmosphere, which blocked out the sun's rays for several years. The long winter had begun. Only there wasn't any snow falling from the sky, but rain made of sulfuric acid. Yes, the Chicxulub incident might just be the most important thing that ever happened in the history of our planet, even more than YouTube. Back then, there were loads of volcanic eruptions, a lot of flammable oxygen in the atmosphere, constant temperature changes. It was the perfect and worst time for all of this to go down. So, how are we so sure about all this? Well, the asteroid left an absolutely huge crater on the planet's surface. Today, this scar is hidden under the Gulf of Mexico. Scientists found a lot of places on Earth with abnormally high levels of iridium. This metal is very rare on Earth, but it's in a lot of asteroids that scientists have examined. Scientists studied some 66 million-year-old rocks. In the layers of rock, they found dust, the same dust that comes from asteroids. This could only have happened if a huge asteroid had crashed into Earth. The catastrophe led to the extinction of not only the dinosaurs, but also the asteroid. It was so hot at the point of impact, part of the asteroid just disappeared. A lot of water vapor and carbon dioxide shot up into the atmosphere. But the biggest problem, sulfur. It got kicked up by the asteroid impact and flew up into the air. These tiny sulfur particles blocked out a lot of the sun's rays. Without the sun, a lot of plants disappeared and the climate eventually got colder. The immense heat turned stones into glass. Scientists call these things tektites. The energy of the impact threw them up into the skies. After a short flight, the tektites fell down to Earth. But it wasn't pretty. Rain fell too, only instead of drops of water, you'd have seen hot glassy fireballs. They bombarded the planet's surface for days. The tektites set fire to everything. Scientists found evidence of this all over the world, not just near the collision site. But a lot of things from back then are still a mystery. Some scientists think that Chicxulub wasn't even an asteroid. It might have been a comet. Asteroids are mostly made of stone and metal. Most often they kind of look like a potato. A comet contains rock, metal, and ice. Comets look like dirty cosmic snowflakes, complete with ammonia, methane, and carbon dioxide. Comets sometimes come from the Oort cloud. It's a huge cloud of ice and debris around our solar system. From time to time, comets break free from the pack and head towards our sun. According to scientists, this special comet flew right past Jupiter. The gravity of that huge planet accelerated the comet even more. It flew towards the sun, gaining more and more speed. The comet's outer ice shield started to evaporate, and it probably gave off a lot of dust and gas, which made it look like it had a tail. The sun's gravity eventually shattered the comet apart. One of the fragments flew through space and crashed into the Earth 66 million years ago. So, asteroid or comet? The truth is, we'll never know. What we do know is that the Earth was seriously unlucky to be in its path, and it was never the same again. The catastrophe stopped the development of 75% of life on Earth. Some bigger marine animals, like crocodiles, turtles, and fish, survived the impact. Out of all land animals, the only ones to survive were the ones that were, on average, smaller than the modern raccoon. That includes a bunch of special species of dinosaurs, the ancient ancestors of birds. Scientists believe they survived for two reasons. After the huge impact, it took a long time for plants to start growing again, and a lot of animals didn't survive. Most remaining animals didn't have enough food. But these dinosaurs had a beak. With its help, they could split open nuts and dig seeds out of the soil, so they survived. The second reason is that these lucky guys had bigger brains. Some people think that they were able to cooperate with each other and quickly adapt to the new conditions. Other life forms survived too. Fungi and mold survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape. After a few thousand years, forests started to reappear. The animals that survived were pretty much all inconspicuous and small creatures. They lived in burrows, safe from all that hot ash. Before the collision, mammals had lived in the shadow of dinosaurs. But with all the dinosaurs suddenly gone, things were about to change. Mammals were able to take over. They began to dominate life, at least on land. Back to the moment when everything changed. Turns out, It wasn't the size of the asteroid that made it so powerful. It was more about the angle in which it hit the Earth. If the angle of impact had been different, the dinosaurs might have even survived the catastrophe. So, what would that have looked like? Well, let's travel back, way back. Oh no, there's a giant asteroid heading for Earth. Oh, wait, never mind, it missed. Whew. There are plenty of earthquakes, tsunamis, and volcanic eruptions every day, but dinosaurs don't mind that much. No big deal. Fast forward a few million years, and most of these ancient lizards have changed and are now unrecognizable. Thanks to a couple of ice ages, many dinosaurs are now totally covered with feathers to protect them from the cold. Mammals exist, but they're few and far between. You see a lot of bats in caves. There are tons of rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, no elephants, or other large mammals. Why become large and eatable when there are so many dangerous reptiles with huge fangs around? There are no whales in the sea. Parrots, hawks, and pigeons are nowhere to be seen. But pterodactyls 2.0 whiz past you constantly. Some are about the size of a helicopter, while others are no larger than a swan. There are plenty of primates, but they're in no hurry to climb down from their trees and walk on two legs. No venturing out into the savannah, no evolution into Homo sapiens. In this alternate reality, open spaces are very dangerous. But then again, so are forests and trees. Nowhere is safe. To get some delicious primate treats, many smaller dinosaurs learned to climb trees. This was already happening back in the Cretaceous period, right before that huge asteroid just missed Earth. Whew, that would have been an epic collision. Dinosaurs have grown wiser since that near miss. Some are even as smart as a modern chicken. A large brain uses a lot of energy, and that's not always a good strategy for survival. Safer to keep brains small and keep making those teeth bigger and pointier. Ah yes, February 14th, 2000. Just a regular Valentine's Day, some flowers and some candy, the beginning of the new millennium, and a good day to make history. Near Shoemaker, which stands for Near Earth Asteroid Rendezvous spacecraft, launched in 1996, finally got a date with asteroid 433 Eros. It wasn't about swiping right, but going around Eros and completing the first soft landing on an asteroid ever. Near almost didn't make it there, because an engine misfire from 1998 brought it into the wrong trajectory, and it missed the target. Yet, engineers decided to let Near do the circle around the Sun for one more year, and it eventually made it. Near Shoemaker was created to find, target, and stalk some smaller space objects for around a year and collect important data about them. This spacecraft got more than 160,000 pictures of the asteroid's surface, which helped with research in the years to come. Before then, some scientists took asteroids for just some random flying piles. Asteroid 433 Eros is indeed the smallest body in our solar system that got its own spacecraft orbiting it. At first sight, this asteroid seems like any other ordinary rock coming from space. Potato-shaped, rotating every 5.5 hours, the size of 2 Manhattans. For comparison, the biggest asteroid discovered is 383 miles across, while the smallest one is around 6 feet wide. Asteroids are actually some kind of leftovers that remain from the early stages of the solar system. The Sun, as we know it, began to get its shape when compressed gases and atoms started blending into a protostar. Smaller grains of debris and dust around the Sun formed into rocks, and as they were crashing into each other, ta-da! They formed even bigger ones. Objects that survive this chaotic and messy party are something we know today as planets and moons. Smaller bodies that couldn't get the status of a planet are called asteroids. They're too small to have any atmosphere, and their gravity isn't strong enough to shape them into a sphere, so they don't have conditions to support life. Most of them end up somewhere in between the orbits of Jupiter and Mars, and simply pass us by at a safe distance, but not Eros. It became the first of near-Earth asteroids, or NEAs. Since 1975, the closest Eros got to Earth was in 2012, around 16.5 million miles away, which makes it about 70 times the average distance to the Moon. It was discovered in 1898 and named after the Greek deity of love. You know, Eros, the arrows that he uses to make people fall in love with each other, the mess he makes with broken hearts. Yup, in Greek mythology, they call him Cupid. Among many other fascinating space discoveries is nuclear pasta. Not like one my grandma makes, true, but not that bad either. The recipe says you should 1. Wait for a star to reach a certain age when it's time for it to explode. And be patient because this could take maybe around 1 billion years. 2. After the explosion, collect its leftover neutrons and stir them until you get an extremely dense stew. Toss in some gravity to taste, and the last step, don't forget to bake it at 1 million degrees Fahrenheit. Nuclear pasta is definitely one of the weirdest meals on the universe menu, but also potentially the strongest material out there. You would need 10 billion times bigger force to shatter a place of nuclear pasta than to break steel. Scientists believe this stuff is that strong because it's incredibly dense, kinda like me. Picture this, 1.3 million Earths squeezed down and scrunched into the size of Toronto. Oumuamua is the first visitor that came to our solar system, something that scientists have been waiting for decades. This mysterious object was discovered in October 2017 and is considered to be a piece of some bigger body formed outside the solar system and torn apart during its journey. Oumuamua, which means scout in Hawaiian, is an elongated body that resembles a big space cucumber, definitely something unseen before. It has non-gravitational acceleration, and no one actually knows how it moves since there are no visible tails or any outgassing signs. Tabby's star is sure among the most mysterious in the universe. It's 1,000 light-years away, 50% larger, and a lot hotter than the Sun. In 2015, scientists noted that Tabby's star's brightness would dim down by as much as 22%. Big clouds of dust could be guilty of that, but this star is too old to have something like that. It's still not clear what could be causing this massive dimming. Nebula are huge clouds of dust, gas, and plasma that never stop dishing out surprises. They can change and take almost any shape: a fried egg, a space head, a diamond ring. A red square nebula is one of the most fascinating space objects. There is no explanation of how and where it came from. It's just a glowing and almost perfectly symmetric box in the middle of nowhere. Around 210 light-years away from Earth, there's the constellation called Lyra. That's where the Kepler-37 system is. Kepler-37b is the smallest planet in it, with under 1/3 of the Earth's mass. It's just a little bit bigger than the Moon. Scientists believe this is an airless and rocky planet similar to Mercury. Moving to Sagittarius B2, one of the biggest molecular clouds of dust and gas in our galaxy. It's located around 25,000 light-years from Earth and close to the center of the Milky Way galaxy. Research has shown it contains more than 50 different molecules, and one is sugary stuff that tastes similar to raspberries. Discovering tasty planets. Space is getting better and better. Fermi bubbles are two mysterious gigantic blobs made of cosmic rays, gas, and dust found in 2010. They hang around the central black hole of our galaxy, one on either side. Bubbles expanded below and above our galaxy over time, so they're now around 50,000 light-years across. No one knows how they got there, but one theory says they're related to the same black holes that occurred about 6 million years ago. Gliese 436b is one of the strangest planets out there. It's extremely hot, yet made of ice. This is a Neptune-sized planet that needs just a little bit more than 2 days to finish a full orbit around its parent star. It's assumed its surface has a temperature that goes up to 830 degrees, but the ice still doesn't melt since the planet has enormous gravity. Black holes are not always supermassive. IGR rests in the constellation Scorpius. and is only 3 to 10 times more massive than the Sun, which probably makes it the smallest black hole discovered so far. NGC 3842, on the other hand, is something we picture when someone mentions a black hole. It's in a different galaxy and about 2,500 times as strong and massive as the black hole in the center of the Milky Way. Venus, the planet of superlatives. The closest planet to Earth, the hottest surface, reflective clouds that make it the shiniest planet as seen from Earth, the biggest number, 1,600, of volcanoes when compared to other planets of our solar system. Also, we're talking about the slowest spinning body in our universe that barely rotates at all. It takes 243 Earth days for Venus to make one single turn. This planet is so slow, you can actually walk faster before it makes a complete turn. Venus goes in the opposite direction from Earth, which is why sunsets there are in the east, while the sun rises on the west side. 55 Cancri E is about twice the Earth's size, with the temperatures of up to 4,900 degrees. Perfect conditions to turn carbon into diamonds. Yup, 1/3 of this planet is covered in carbon, which makes this diamond object one of the most expensive planets. Scientists who observe space changes in Antarctica see neutrinos at least once a month. Still, this one that struck our planet in 2017 was really special. It was the first one they could trace the origins of. They discovered it took 4 billion years for the neutrino to reach the Earth. It got to our planet from a massive black hole at the center of a galaxy that had been destroying all the matter surrounding it. Hey, welcome to the new neighborhood.